All right, so let's start graphing some of these. 5 and 6 we'll do together in class in case you're wondering what the heck's going on there. So, graph each radical function, identify the key characteristics. So we're going to fill in all this stuff once we've graphed it. So this is saying f of x equals square root of x plus 5. So we're going to do kind of like how we did the logarithms and exponential functions, where we're going to make two different tables depending on, well, I guess the number of tables depends on how many transformations there are. So since this has your basic parent function plus one more transformation, we're going to have two tables, okay? So we're going to start with the basic parent function, and then we're going to add 5, okay? So since this is a outside the radical, this is a plus k, this is adding 5 to the y value, so it's going up 5, okay? So let's make our tables, and remember, we're going backwards. We're not plugging in -2, -1, 0, 1, and 2. That's not going to give us anything we want. We want to end up with whole number perfect squares, okay? Or not perfect squares, we just want whole numbers. So I want 0, 1, 2, 3, and 4 to come out of this function, which means I need to square each and every one of these to get the square root to be that, okay? 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, okay? And the reason I did that, because now I can figure this out, I can plug it into my function to make sure it works. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, yes, it works, okay, we're good. So now that I have my points, I can apply this. I'm going to add 5 to each of my y values. My x's are going to stay the same. I'm going to add 5 to my y's. So 5, 6, 7. All right. And that's all I have to do to plug it in. Now I just have to plot the points. So 0, 5. 1, 2, 3, 4, 5. 1, 6. 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. Okay, I'm not going to go slow with the plotting because we should know how to do this. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. And 16, 9 won't fit on my graph, so there we are. Which makes sense, because if normally the parent function is down here looking like that, it's shifted up 5, so it looks like where it's supposed to be, which is great. All right, domain. My domain is all numbers bigger than 0. My range is all numbers bigger than 5. Since it got shifted up 5, all of my range has now been shifted up 5, which means my turning point, or my end point, got shifted up 5 as well. It's now right here at 0, 5. Okay. End behavior, as x goes to infinity, my function also goes to infinity. Okay. As x goes to 0, because it cannot go less than 0, my function goes to 5. Okay. Is it increasing? It's increasing forever from 0. Remember, x values from 0 till infinity. And it's never decreasing, so we can put NA for that. NA stands for not applicable, in case you were wondering. Okay, so we're going to do one more together, and then we'll do the last 3 in class. All right. So I'm pretty sure all of these, yeah, and I'll show you, you can cross off certain ones. I'll tell you in a second once we finish this one. Okay, so this one, I have my basic parent function, 1 transformation, 2 transformations. So I'm going to have 3 tables on this one. So I'm going to start out with my basic parent function, which is just a square root. Then I'm going to do the x minus 1. And then I'm going to have square root of x minus 1 minus 4. And here we have to figure out what the heck's going on in each of these transformations. But first we can just do our basic parent function. Stupid bells. They're throwing me off because I'm not supposed to be here at school. I mean, I can be here, it's just, it's break. We all should be on vacation. Okay, so this table is gonna look exactly like this table right up here. So you can just basically copy this one down here. Okay. Because it's the same function. Okay, so just copy this table down here. A lot of these, unless you're dealing with a cube root, will start out with the same table. Okay, now let's tackle this -1. Now, if you remember back with the logarithms and the exponentials when we were graphing those, when it was inside the function, I did the opposite of what it was telling me to do to the x's. So even though this says x minus 1, that means it's being shifted to the right. So really I'm adding 1 to all of my x's. Okay, so I'm not subtracting 1 from my x's. I'm going to add 1 to my x's. Okay, so my y's are all going to stay the same for now. And I'm going to add 1 to all of my x's. So 1, 2, 5, 10, 17. Okay, and then finally, this is on the outside. And it does exactly what it wants me to. I'm going to subtract 4 from my y's. So now my x's are all going to stay the same. I'm going to minus 4 from all my y's. Okay? So I subtracted 4 from all my y values. And now we can plot. 1, -4, 2, -3, 3, 4, 5, -2, 10, -1, and that's as far as I can go. This won't fit on the graph. So, here we go. Okay. What was I going to say? Yeah, we'll stop there. Actually, you know what? Yeah, that's it. That's as far as we can go. We cannot go back. Right, okay. I was thinking we could go back to 0, but we can't because that would require changing the x to a negative number. So no, we cannot. So our domain, all of our x's are bigger than 1. X is greater than or equal to 1. Okay, because if I use 1 minus 1, I get 0, and I cannot have less than 0. Okay, all right. My range, all of my y values are bigger than -4. And that number comes from right here, and I can see it on the graph that all my y values are bigger than this number right here. My turning point is right here at 1, -4. I guess in this one it's my endpoint. Okay, as x goes to infinity, my function also goes to infinity. As x gets closer and closer to 1, my function gets closer and closer to -4. This and this will always be the same. Okay, and this. These three will always be related. Okay, it's increasing always, so from 1 until infinity, and it's never decreasing. So we're going to do 3 of these together in class. You are more than welcome to try them on your own. And in fact, I do encourage it, just like I said before. Okay, so I want you to turn the page because we're going to do 9 together. And I want you to cross off, just so that we're all on the same page. Oh, where did it go? Oh, right here. Number 10, cross off number 10, and cross off number 13. Okay, those ones have more than 2 transformations, and I'm never going to give you more than 2. I'm going to give you up to 2. So again, you're crossing off 10 and you're crossing off 13. Okay? And then in your practice quiz, you flip to the very last page, you're going to cross off 7 and 9. Don't do 7 and don't do 9. Okay? But you can do the other ones. So practice quiz, cross off 7, cross off 9. Everything else you can do. And the notes, cross off 10 and 13. And I'll repeat that when we come back. So All right, so that's it for concept 5.